Welcome to our Chapter 2 examples. This file is quite long compared to some of the other examples. It's, in my opinion, fairly difficult to divide annuities into these made sections in the textbook. So I'm rather just going to go through all of them in one go, keeping only the last two sections. Section 2.5, complex annuities. But even that section 2.5 is identical to 2.1 to 2.1 to 2.4. The only difference with complex annuities, if you had to look at the theory document for this section, you'll see I mentioned it there. There's one extra step. You need to change an interest rate before you do anything. For these examples in this document, the interest rate that we give you will be the one that you need for making the payments. And then there's 2.6, 2.7 increasing and decreasing annuities, which we'll get to right near the end of the semester. So this is 3 weeks worth of examples. I'm not going to do all of them. Most of them, or most of the more difficult ones, have counterparts in the tutorials, and those will be the ones we spend a lot more time on. So if we get started, example 1 on page 47. Person invests 1,500, end of each month, savings account. How much will be in the account at the end of the 5th year? So the two things to be on the lookout for here: 1,500 end of each month. So that's when the payments are. And secondly, what do we want? How much is at the end of the year? So we've got two time periods that are always at play with us. So on the one side, let's do that in red, you have your payment. So that's the annuity amount. In this question, that is the 1,500. And then we have, I'm going to call it single amount. So where do you want the single amount for this? So this can either be a future value or it can be a present value. So we have these two time periods that are always at play when working with annuities. The red is your actual payment. When, how many of them. The blue, future value, present value. So for this one, how much will be in the account at the end of the 5th year? So I'm looking for a future value. Now, if you look carefully, I'm doing that in blue because that is the single amount. Do you want that single somewhere in the future? And in our case, yes, after 5 years. So now that's the notation for a future value of an annuity. Now this annuity itself is 1,500. So that goes in front of the S. At the end of each month, I'm going to draw a little circle on top of the S just to remind ourselves, if this 1,500 is at the end, I'll need to do something. But don't draw that, well, you can draw that circle. I'm not going to see an equation that you do. It's just a way of me remembering that sometimes there is actually something on top of the S. 1,000 at the end of each month, interest rate 15% monthly. So I'm allowed to write the interest rate there. It needs to be monthly, and we are given a monthly interest rate, 15%. And 5 years, end of each month. So number of payments year, you are looking for the blue value in 5 years' time. And in 5 years, there will be 12 payments. So that is your little equation. You see that top of page 48. And you'll also see all the calculator steps on page 48. The reason I started with this one, yes, it is a basic one. I like this, the way that I'm going to do this going forward, always using the two different colors. The one color is telling me in terms of the longer time period that we have. So the blue color refers to this long timeline, and in our case 0 to 5, and then the red color, or whatever the second color is that I may be using that day, will be referring to the thing that repeats. In our case, that is the annuity. So those would be the two timelines if you ever hear me, two time periods if you ever hear me speaking about that. As I said, calculate the steps, page 48. You can go and look at the document as well for the calculator help. I'll show it's shown in there how to do this. Example number 2, I've highlighted it in yellow and in red, so it should tell you it's fairly important. And the reason this is important, there are two things that can change for an annuity, exactly the same two we had when working with single amounts. So the two changes you can have the interest rate that goes down or goes up. You can have the payment that goes down or goes up. So the same two set scenarios as before. Interest rate goes up or down, or you add more money to the account, you take away money from the account. That's what we had in chapter 1. And if you can remember back, what was the golden rule when working with this? You stop at that point in time. So you take your timeline. If you have 3 interest rate changes, at every point where the rate changes, you calculate a future or present value. Some of this our calculator can do in one step, but we still need our equations. So we're told in this case for a period of 8 years into a bank account, initially we've got a rate, and then since the beginning of the 4th, the rate was changed. So I'm going to have my black timeline. Period of 8 years into a bank, interest rate monthly since the beginning of the 4th year. Now just get your timelines correct. Where's the beginning of the 4th year? So that's the end of year 1, end of year 2, end of year 3 is the beginning of year 4. Then 4, 5, 6, and 7. So this interest rate, and that's the sticky point for this one, initially since the beginning of the 4th year. So at this point in time, my interest rate changed. Before that, it was 15% monthly. And after it, or after that point in time, it changed to 18%, also monthly. So the change in the rate is not necessarily the difficult bit here. It's that a lot of you don't run off immediately. I tell you at the beginning of 4 years, you go and draw that green dotted line at 4, and going forward, all your number of payments are incorrect. Find the accumulated amount at the end of the 8th year. So in terms of my long timeline, I'm looking for a future value. But the way that we have to do it, this is going to be annuity 1, that is going to be annuity 2. So we have to split it up into these two calculations. So for annuity 1, I'm going to get a future value. For annuity 2, I'm going to get a future value. The payment for both of them, 900 at the end of each month. So that's a 900, nothing on top of the S there. That's a 900, nothing on top of the S there. First one is 15% monthly. I need a monthly rate, so that's fine. Second one is 18% monthly. So that's also fine. It's 3 years monthly for the first one. Make sure you know why 3, beginning of the 4th year. And then it is 5 years monthly for the next one. So those will give me my future values for this 2 annuities. There aren't really 2 annuities. Again, in actual reality, you just keep on making your payments. But in terms of our equations actually being able to do this, we have to split it into 2 parts. The first one, this is the future value of that annuity there. The second bit, that is the future value of that part of the annuity where the rate has changed. I'm just going to delete the red circles on top. They're just taking space for now. And now if you go back to the theory document, you'll see the last example I did showing you that we can now replace all of our payments with these two single amounts. So these amounts are single amounts. Where am I looking for my single amount? I'm looking for it after 8 years. That's where we want the answer. So this second purple bit 900S60 is exactly where we're looking for it. The first bit of an issue. I have an answer there. I want an answer there. What do you do if you want an answer somewhere in the future? You multiply by a bracket. And here, be careful. It's the new interest rate, which is 18%, and that is 60 months into the future. And that's the equation we have for this one. So you've got the 900 at 15% for 3 years. Then that you look at as a single amount. It just sits in the account earning interest for 5 years. And then you've got the second annuity for 60. So on the next slide, I'm just going to write down the equation again and then show you on the calculator how you can actually do that in your calculator. So if I just rewrite the equation so that we can follow the calculator steps. So we have our two annuities, both of them 900. One is for the first 3 years, so that's 36. The other one's for the remaining 5 years, so that's 60. And then the reason for all the fuss, we have two different interest rates, the first one being 15, and that then changes to 18. The first annuity goes, so let's do this, you start the beginning at 0, and then it goes to 3, and then from 3 to 8, the future value, I'm going to say plus minus, that becomes the present value, and then the future value for the next one. So this is what the calculator will do. We need to take in our equation that and move it to there. So that's in our equation. This gets added. But the calculator's present future will handle this correctly. So the fact that we start with a present value, the calculator knows to take that and take that into consideration when calculating the future value. So that's the idea behind this. Make sure you understand that. Similar to a present value future concept we had in chapter 1. So on the next slide, I actually have the calculator steps for the package that I use to connect the calculator. It needs to be a blank page with just the calculator video on it. So you'll see the equation again, and then me going through the steps. And the important bit, we have one annuity for there. We have a second annuity for there. And the second annuity just starts with a present value. The first annuity, present value is 0. The second annuity starts with the first annuity's future value as its present value. So the step the calculator is going to save us time on when doing this is the yellow bit in the equation. I actually don't need to do that yellow bit. By using my present and future values correctly, the calculator will take care of that yellow movement for us. So we just clear everything, and then we do the first bit, which is 900 payment. Let's just see, is this into a bank account? So to be 100% correct, this needs to be a negative. So negative payment, he pays it into a bank account. 0 present value. This is 15% interest to start off with. The payments are monthly, and note my distinction. It's not the interest rate that's monthly. It happens to be monthly, yes, but the more important one is the payments are monthly, making this for 3 years, and that is the future value, 40,603. So after 3 years, that is what will be in the bank account. And now the only thing I need to do for the yellow bit, I need to, remember this is still lying in the bank account, so we put it a negative and make it the present value. So now for the last 5 years, the calculator knows there is a present value to start off with, so it will be taken into consideration correctly. The payments were still minus 900. Note both of these minuses. The bank has got the money. The bank has 40,000. You are giving the bank 900 more every month. That's not changed. The rate changed to 18%. So we change 18 interest rate. It's already 12, so I don't need to do anything there. And it is now for 5 years. 60, and you press your future value button. And what's this? Jacobus will get 185,797 Rand and 57 cents in exactly 8 years' time. Same answer you see top of page 49. And this is why this is an important example. To show you can use the present and future values exactly as we had when working with individual amounts. The critically important bit here is you need to make sure about your signs. If you look carefully, I have minus 40,000 there. I have minus 900. 40,000 is currently lying in your account at the bank. You are giving the bank an extra 900 every single time. If you don't have this the right way around, if that is a positive and a negative, or negative and a positive, you will run into issues for this one. Our next example that I'm going to look at is example number 4. Just briefly mention example 3. In the textbook for example 3, you'll see for some reason the author goes into using logs to solve n and the actual equation for s. You can pretty much just delete all of that. We're never going to use s's or a's equations. If you look at the theory, but I never even gave you those equations. We use the calculator for everything. So in example 3, it's only the steps at the bottom of the page that we need to look at. Example 4. A person borrows 50,000. Now this is, let's start. There are 2 ways that you can repay a loan. Usually you have the loan as your present value, and you calculate your monthly payments to repay it. That is called the amortization method. We're going to look at that in chapter 3. Or a second method of paying off a loan, and this is what's going on in example 4. You get your loan, and then being a prudent financial person, making sure you sort it out in the future and all your financial affairs are in order, you know that you have to save to repay that loan. And that is what's going on here. So we need to have that 50,000 Rand somewhere in the future to repay this loan plus interest at the end of the term. So it's a roundabout way, an easier method. I'm going to put this up here. So an easier method to have done this is 50,000 present value, give the interest rate, and calculate your payment. For this question, we're not going to do that. So in 10 years' time, this individual needs money to repay the loan. So in 10 years' time, and this is now again, we've had similar examples before. You'll hear me saying this fairly frequently. Chapter 2 is just chapter 1 with repeated payments. He needs to repay 50,000 in 10 years, but note carefully 50,000 plus interest. So I've got my bracket in there. So that's in 10 years from now. 14% per unit per annum. So it's just 14%. So over 1, and that is for some reason I've got black. Let's change it to purple. It doesn't really make that big a difference. 14% yearly for 10 years. So that's what he needs to pay. And if you look carefully in your textbook, you'll see that answer 185, was it 361.07. You cannot put this as the future value in your calculator. You can't put 50,000 future value and think the calculator will handle this correctly. We need to calculate what the actual loan amount is using its interest rate. You'll see there 14% per unit per annum. And now we're done with the loan. So we've calculated once. So all we have, I can get rid of all that 50,000. In 10 years from now, he needs 185,000 Rand. He's going to do that by investing money. So this will be, or this is the future value of an annuity. So that's why I've got the purple in there. It's for the 10-year time period. He's going to do that by making provision for this end of each term. He's going to deposit X, so off to red. So that's my new color. At 13% per half year. Now be careful. Let's make sure what is X. X at the end of every 6 months. So I have to have a 2 there. There's nothing on top of my S, so no dots or anything. Make sure end is on your calculator. I need a half yearly interest rate. Let's see, 13 half yearly. That's exactly what we're given. So I'm allowed to write the 13 there. Not because it's what we're given, because that's what I actually need for X. And he's going to do this over the 10-year time period. So that purple amount is needed in 10 years time. The payments are twice per year. And that then must equal 1853. So you see the solution for the calculator, bottom of 50, top of 51. You first calculate the 185,000. That then is your future value, and then you do the annuity bit. So we don't confuse these two. Getting the 185 is a single question. Once you have the 185, then you are back to the annuity part of the question. Another way that you should have picked this up, we have two different interest rates and two different interest periods associated with them. Example 5 continues from example 4. Immediately after the person in example 4 made his 8th deposit, the savings account was raised to 14% half yearly. Determine with what equal amount each of the remaining deposits can be decreased. Note, decreased, he's earning more interest. If you earn more interest, you actually need less money. So the first thing we need to figure out is how much does he still owe, or how much should he still invest at that point in time. So he's made 8 payments. Let's do black. So this 20 payments in total. This is a 10-year time period, so I'm moving over to half yearly. And from example 4, we have 185. What was that answer? 361. You can go and add the decimals you want. So that is what we have, and he's made his 8th payment. So 1, 2, 3, 4, 5, 6, 7, and 8. These payments were all our answer from A. So all of these are 4774 point. What's that? 23. And then immediately after the 8th one, so he's made 8 of them, the interest rate raised to 14 half yearly. So that's the new bit. From example A, we have, it was 13%. So that's all the information we have. And we need basically to calculate, what's it, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So those remaining payments. So on this side, he's had 8 of them. That means there are 12. 8 left on the one side and 12 left on the other side. And what we do is we split this as we did, what was it, example 2, where we had an interest rate change. Here we'll have exactly the same scenario. I have the future value of 2 annuities. The one annuity is the 4774.23. That's running for 8, and it has a rate of, so used to monthly, this half yearly, of 13%. Then there's a new annuity. I don't know what the payment is, X, but that will be for 12, and that is a new rate of 14%. The first one will be at 8. That equation will be at 20. That's not going to help me, so this needs to earn interest at the new rate for 14 half yearly for 12 periods. So I've rewritten the equation we had in example 1 as well. And all of this must equal, right at the top, the 185,000 that I wrote there. So that is the equation we have. On the calculator, the steps are a little bit more involved. So on the next slide, I'm going to rewrite this equation and then just talk you through the calculator steps for this one. Very similar to the one we did before, also present value and future value. But now I'm going to get a future value first, save that, then a present value, and then I'm going to press my payment button to do this. So a little bit more, I don't want to use the word involved, a little more steps, so that purely because I don't want to write things down on paper. So I'm going to do all the calculator steps just so that there's no need to write anything down. You find the steps bottom of 51, 52. I'll just show you on the little online screen grab how to do that as well. So copy and paste this equation onto the new slide, and then there all the calculator steps. So for example 5 on the calculator, I'm going to go back to example 4. I need to get that final answer, the 185,361 that you see in the equation. I've left the decimals off. Just add them if you want. I don't want to write that down. So how did we get that value? So that was 50,000 that he borrowed. Present value. 14% interest. Once per year. For 10 years, 0 payment, future value. So that's the 185,361 that we have as an answer. So that is the future value that he wants back. So plus minus to get out of financial mode. So now that's set. So that becomes my future value. As I said, you could have written this down. I want the calculator to keep all those decimals for me, so I'm not going to write it down. Next thing, I want that 4774's answer. So I want that saved in my calculator as well. How did we get the 4774 from example 4? So it was twice per year is the payment. Future value, present value 0. Remember, there's still a future value saved in there. This interest rate is 13%. Twice per year I've already pressed. 10 years and payment button. So there I have the 4774.232 from question 4. So now I have the future value in there. And I have the payment in there. So what I need to do now is save some of these values into my calculator's memory. So I want to make sure what the new payment will be. Future value, I'm going to change that in a second. So I'm going to put that into memory. Arrow M saves that into memory. I'm now going to do the 0 to 8 bit. So I'm going to get a new future value. So I'm going to remove the 185 from memory. So that's why I'm just saving it. So that goes into memory. Now for 8 payments, 8N, how much will he have in his account after that? 48,109. So on my timeline, this is what will be in the account after 8. Negative, that becomes present value. So this is what he has in his account at 8. What does he want in his account? So now I'm going to use my memo saved button. So I'm going to recall. That is what he wants in the account. So now I'm looking at the 8 to 20 time period. So at 8, he will have the 40,000 that I've already pressed, 48,000. This is what he wants. It's a new interest rate, 14%. This is for 12 payments, and we press our payment button, 4308. So that's what the new payment is that he needs to make. And you can subtract that from 477 to get the answer. Let's just see. The question is, determine with what equal amount each of the remaining deposits can be decreased. So this is the new one. The old one, there's a negative in front, so look carefully. I'm going to add the new old one to it. Note there's a minus, so I'm basically subtracting. Plus the old payment was 477, 4.23. So you can decrease his payments by 460. So go back, look through this again if you're unsure. Went back all the way to question 4. The reason for that, I don't want to save, I don't want to write things down. I want the calculator to work with as many decimals as possible. Now, example 6 on page 52, I've marked as important, not because it's difficult, but because it's something we're going to use fairly frequently. And it is similar to what we've had before. At this point in time, I can change from one nominal rate to a different nominal rate. Nominal effective buttons on the calculator. So if I have a bank that's giving me interest every month, I can change or compare that to a bank that gives me interest every quarter. Example 6, we're going to do something very similar. The difference there is I can change a specific payment into a different type of payment. So how can I, if instead of making monthly rent payments, you want to make one, well, let's say every 2 months. Certain countries, people get salaries not every month, as is the norm in South Africa if you work at big companies. Some countries you get salaries every 2 weeks. Some other places you get weekly salaries. So if you have weekly salary, or if you're making payments every month, but you're getting weekly salary, maybe it's better to make your payments every week. So how can I change a monthly payment to, say, a weekly payment? Nobody is better or worse off. You're just changing the frequency of when you make your payments. And that is what example 6 shows, and we're going to do quite a few of these in the tutorials. So a pretty standard question you'll get asked in theory of interest. You have a specific interest rate, change it to a new interest rate. And in this chapter, you've got a specific payment, change that to a new payment. And the important thing there is, we did it in a previous example, always remember you've got your longer timeline and you've got your annuity. So the black is either an A, let's use a black color, if I'm looking for it there, or it's an S. Everything in and around is then determined by the red. So for this example, if I'm looking for present value, there are 1, 2, 3, 4. There are 5. That's an X there at the end, and you'll have an interest rate. if it looks something like this. So if I've got the 5 purple ones, if I'm looking for S, it's still 5x, but now the purple is at the beginning of each time period, and you'll have the interest rate associated with that. So the longer time period, the year or the 6 months or the 2 months, where that is located, that is the present or the future value. The shorter one, the thing that actually repeats, determines if it's in advance or in arrears. So that one slide on the theory where I went into quite a lot of detail for in advance and in arrears, dots or no dots, will start becoming important. And the way that you tackle these questions, Mr. Foster invested at the end of each month in a savings account. What equivalent amount could she invest at the end of each 3 month and end of each year? So we've got 3 time periods here. We have monthly, I'm going to 1 over 12, at the end of each 3 month time period, so that's every 3 months, and we also have end of the year, so that's every month. So those are the ways that I'm going to do it. And we want to change, firstly, from month to 3 months. So I want to change from that one to that one. So how do we do this? You go and draw your timeline for the longer time period. Now, which one of these two is longer? Well, a 1 month time period is shorter than a 3 month time period. So that's 3 months. So you go and draw your longer one. On there, you go and draw your shorter one. How many month periods are there in a 3 month time period? 1, 2, and 3. So that is my annuity. The 3 months is the longer of the two, and that will play the role of present or future value. We're told what equivalent amount could she invest at the end of each 3 month period. So it's the end of the black one, and the 1,000 is also at the end of each one. So that's the little timeline that we have. So in terms of my longer timeline, I have its future value. It's at the end of each 3 month period. The shorter timeline, X, there are 3 of them, and important, the shorter one, the thing that repeats, it is monthly. So I need a monthly interest rate, and the X's is at the end of each time period. So there's nothing that I'll put on top of the S. So that's the little equation we will use to change from a monthly to a quarterly. Every 3 months is a quarter of a year to a quarterly payment. And these 2 different time periods are the important things to understand. Students here tend to get confused. When is it an A? When is it an S? When should I have dots on top? And what is the interest rate that we're using? And that's why I find the colors can be helpful. The longer one, everything in black. The annuity is actually the thing in red, and that drives everything in and around the S. So for this one, if I put the values in there, we're told, so we're looking for X, S, and you have it in your textbook. I'm just going to add it in here. That is 1,000, that is 3, and the rate is the correct one. I'm given the monthly interest rate, so I need to work with it. So payment will be 1,000, 3 times per year interest, and you press your future value button, seen at the bottom of page 52. The next one, and I'm going to start all of these exactly the same. Hopefully it becomes a little bit boring. Just get rid of all these dots that I drew. So pick out which one is the longer one, pick out which one is the shorter one, and from there we can decide what to do. So now I want to go, let's use green, I want to go from there to there. So I've got a 1 month or a 12-month time period. Well, the longer one of that two obviously will be 12 months. So that's 12 months. The shorter one, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that would be the monthly one that repeats. What equivalent amount can she invest at the end of each year? So that's where the value is, and the thousands are there. So that's where she's making the payments. So in terms of the longer time period, X is the future value of this annuity. The annuity is 1,000 Rand. It's at the end of each month, so I'm not going to put anything on top of the S. There are 12 of them in a year, and the rate is still 12.5% compounded monthly, which is exactly what I need. So that will be that one's answer. They'll become trickier in the tutorials where we combine future values and present values and annuities in advance and annuities in arrears. So then sometimes it's an A with a dot, sometimes it's an S without the dot. But if you if you do them in this fashion, make sure you get your shorter and your longer time periods. Draw your timeline if needed. Use 2 different colors. You should have no issues with these examples. Next one, example 2 on page 55. Individual withdraws at the beginning of each year, starting immediately from a fund, 15,000 there. What balance will be left at the end of the 8th year? Make sure it's again one of those end beginning of a year, so we need to make sure where they are. Starting immediately, a fund with an initial value of 15,000. So we've got 7, just to make sure, I'm going to do this 7, 8, 9. Let's just make sure where those 6, 5, 4, 3, 2, 1. 15,000, so there's 15,000 sitting there. She's going to start taking out immediately 2.5. There's going to be 1, 2. So first year, second year, third year, beginning of 4th year, 5th year, 6th year, 7th year, and 8th year. So that's up to the beginning of the 8th year. So what amount will be left in the fund at the end of the 8th year? So the question is, how much money is there? Now, this will be stated clearly in a question. Here you can assume the question should actually be what balance will be left at the fund at the end of the 8th year immediately before she makes a withdrawal. So the question is just before she makes a new one. So let's say just to the left of the 8th. I want to know how much money is there. You could approach this in a slightly different way. If I tell you how much money will be left there immediately after the withdrawal, and you will see examples of that in the tutorials, so we'll take a look at that when we get there. So 15,000 present value, we're looking for future value, and we have this annuity. So I want to know what will be in the account somewhere in the future, and that will be made up of 2 things, because the 15,000 earns interest for 8 years, and then minus the future value of that annuity. Remember, for annuities, we need to split up these into different bits, or rather, for our equations, I have 3 values here, 15, the question marks, and then the annuity, and there are 8 of them. So we split them up into different bits. The calculator, we can use present and future values. So on the calculator, you can do this in one step. But for our equations, each amount is its own separate entity. So we have a single 15, we have the 2,500 annuity, and I have the single question mark. And we're moving all of this to the end. Just clear that up a little bit. Question mark doesn't look like that. There we go. The rate 12% per annum. 12% per annum, and here at the bottom. Now, I'm very specific reason for doing it this way. The yellow could be any interest rate. When you work with a single amount, there isn't a set rule for what interest rate to use. I could have used a monthly rate. If I used a monthly rate with the 15,000, it would have been 8 times 12, so there would have been 96 months. So I would just have adjusted the power to fit the interest rate. When you're working with an annuity, yeah, this must be yearly because that one is yearly. The yellow bracket could be anything. If it's half yearly, that would have been a 16 and that would have been a different rate. So yellow isn't determined by a single amount. But here the red 12 is there because of the red 2,500. And lastly, keep in mind the 2.5 is at the beginning, so we need to make sure that I have my dots there. And don't be put off by the timeline. Remember, an annuity in advance, the future value is given at the end of that month. So the payments that you see here, that is month 8 or year 8's payment. That is that one. Go and look at the theory section where I covered this as well. So this annuity actually ends after 8, and that's where the future value will be. So this amount is at the correct point. It's not going to give me the answer at 7. If I have the dots there, instead of giving the answer at 7, it actually gives me the answer at 8. Without the dots, this would have been at 7. Go and look at the theory section. So the dots basically just move it one period on your timeline. So not a difficult one, but again, all these small niggly points where you can quickly lose marks in an assessment. You think you've done okay, and you have the equation correct. And all of that sorted out. You just read slightly incorrectly. Beginning of the 7, all of a sudden becomes 8. You put that value at 8 and you turn off the dots and all those types of things. And it can just mess up your theory of interest mark. Some of you repeating this would know that. You walk out of the venue. Well, some of you would have walked out of the venue knowing full well you did fairly badly. But often you walk out of a theory of interest venue. Everything was perfect, but you're expecting a mark of 70 or 80. And all of a sudden you're getting 20 and 30. And if you go and look at your paper, it's these small things. This beginning of 7, you actually went and put there. So your whole timeline was wrong starting off with. If your timeline's wrong, all your equations here at the bottom would be wrong as well. Next example, example 1 on page 59. I forgot to mention example 2. You have all the calculator steps at the bottom of page 55. So please go and take a look at the calculator steps. Everything is given there. And just make sure about the value of your present value and your payment. They need to have opposite signs. Example 1 on page, where are we? 59. Find the equivalent single amount that should be invested immediately instead of investing 1,300 at the end of each month for the next 6 years. I'm not going to even draw a timeline for this. Find the single amount that should be invested immediately. Immediately means I'm looking for a present value. So that what should happen today. That's the present value of an annuity. Instead of 1,300 at the end, so I'm not putting anything on top of the A, it's at the end of each month. It's monthly, so I have to have the monthly interest rate, and whatever time period must be multiplied by 12. It's for the next 6 years, so this is a 6-year time period that we have, and the interest is 15% monthly, which is exactly what I want. So this is now getting to present values. So it's actually a completely new section. You'll see we've now moved on to section 2.3. But in reality, all the changes on our calculator in section, what was it, 2.2, you pressed future value. Yes, future value. Here you would put in 1,315, 12, 6 times 12, and just press your present value button. And that's one of the main reasons that I do this as a block rather than individual sections, because in reality not a lot has changed. You find the steps on page 60 in the middle. So now we can do present and future values. And keep in mind, on your calculator, A means I need to press present value. S on your calculator means you press future value. And the dots on top, if there are dots on top, this just means begin must be on. If there are no dots on top, that means it's just blank at the bottom of your screen. Please don't go looking for the word blank, or please don't go looking for the end. It's just the default on your calculator. Example number 3 on page 61. On 21st birthday, sum of money was placed in a trust. From this trust, he will receive 800 for the first 5 years. Thereafter, 1,000 for the next 6. Money is worth how large? So this, we've done this before. A change in payment. We just did it for future values. Now we're doing it for present values. And the underlying principle always. So on his 21st birthday, so that is his 21st birthday, this he will receive for the first 5 years. So this up until his 26th birthday, that would be 5 years. And thereafter for another 6 years, so that would be up to his 32nd birthday. So we've got 5 years there, 6 years there. And what I was starting to say, principle is whenever something changes, we're going to stop our calculations. I have to stop there. This bit will be one annuity. That will be a second annuity. I will get the future and present values for those, and then I will treat them as individual amounts working forwards or backwards. So we do chapter 2 to get present value or future value for these two parts of the timeline. And then we do chapter 1 to move them to wherever we want. The question here is, if the money is interest, how large initial sum? So we are looking for that value. So that means everything that will be worked backwards, that will be worked backwards to there, and once it's there, I will work it backwards to there. So the blue arrows going backwards, those are for annuities. Then the yellow arrow means just a bracket or a V from chapter 1. Because I'm going backwards, this will be an, let's stick with the same color as the arrows. That will be an A. That will be an A as well. From his trust, he will receive 800 for the first 5 years. And then 1,000. This is monthly. That is also monthly. So we need the monthly interest rate. That is exactly what we're given, 15%. There, 15% there. The first time period is for 5 years. Second block is for 6 years. So this is the value of that part of the annuity there. This is there. So we split it into two parts as we have to. What I'd ideally like to do now is add a plus sign there. I'm not allowed to add a plus sign. The one is on 21, the one is in 26. How can I fix that? This amount needs to go back for 5 years. Why 5? needs to go back from his 26th back to his 21st birthday. And I'm going to do this monthly. I don't need to do this monthly. You can use any rate that you want, but it's a monthly rate. And finally, that means I can solve for x. So 2 A's and a V. In a previous example, we had 2 S's and a bracket. So that's the difference between these. Moving backwards, it's AAV or AVA or whichever combination you want to work with. Moving forwards, it would be S bracket S, usually. We're going to use the same trick as, well, not a trick, we're going to use the same built-in functionality of the calculator. Get the present value of the, or get the present value of the one, change it to a future value. So in terms of the calculator, all the steps are there on page 61. So I'm not going to do all the calculator steps again. I've done this now twice. But on the calculator, you're going to do this bit first. So that will be step 1 on the calculator. So you have a future value there. You get a present value. And then once you have that, this present value becomes a future value. And then let's make a little bit neater. Present value becomes a future value. And then you do that on your calculator second and get present value. So that's the order that you do it in the calculator, working backwards. So you start here with no money in the future value and work your way backwards to actually getting your present value there. All the steps on page 61 that you can follow. Next example, example 1 on page 63. It's got to do with annuities due. And here you see 2 methods of doing these things. So those of you with your textbooks, if you look on page 63, different methods of doing this, and you can get an A with a dot by using the 1, all those types of things. Definitely not something we're going to do with our calculators. We turn the begin on the calculator and that's it. So we're told Mary buys clothes for which you will pay 13 monthly installments. So first on the day of the purchase. Interest is calculated for such higher purchase transactions at a rate of 18% monthly. Find the marked cash price of the clothes. So we're looking for the cash price. So that means it's an A. It's the present value today. 150 Rand. 13 of these. They are all to pay monthly. So that's the information we have. And on the day of purchase, she makes her first one. So that means I have my dots on top of the A. Interest rate 18% compounded monthly, which is exactly what I need, so I don't need to change that. So there's this equation. Why 13? Because we're told there are 13. It doesn't matter if she makes the first one now or if she makes the first one in a month's time. There are 13 payments. That doesn't change. The fact that she's making it now just means we're going to add the dots there. So the 13 is what we're given. There are 13 of them, so don't go playing around with that, thinking about in advance or in arrears or anything. The dots, because first one is actually today. So on the calculator, you would turn begin on and you would do the question from there. So don't take a look at the equations. For some reason, the equations there at the bottom, they get rid of the dots and then go further. Well, there is a reason. Years ago when we had theory of interest, no calculators. We used to use what were they called, textbooks with all the values in there. So we had a book that we went and looked up all of these different coefficients. So there were a couple of tricks that you had to do by hand before you could actually go and look up in these books the different values. But now our calculator can do this, so no need for any tricks or getting rid of anything like that. In advance, dots on top, 13, 13, 150 monthly interest, and you ask for the future value. Example 1 on page 67. So now we get into deferred annuities. Now for deferred annuities, you need to make absolutely sure where the answers for your annuity is that you'll get when you press the present value button, and where do you want the answer in terms of the timeline. Remember, deferred annuity just means you get something today, but then you wait a while before you start making your payments. So it may be 3 months or 4 months or something like that, but you wait a couple of months before you start making a payment. So that is what's meant by a deferred annuity. So let's take a look at example 1. A student who registers for a 4-year degree course borrows X to pay his studies. He agrees to pay the debt by making payments of $15,000 per year for 8 years, first installment at the end of the first year after graduation. So that's the deferred part. So the student starts studying a 4-year degree course. So 1, 2, 3, 4 years. So that's the 4 years that we have. He agrees to repay the debt by making payments of 15,000 Rand per year for 8 years, the first installment at the end of the first year after graduation. So that is where the first payment will be. That's where 15,000 is made. 1 year after graduating. And he's to be paying per year for 8 years. So that's 1, 2, 3, 4, 5, 6, 7, 8 of them. So 6, 7, 8, 9, 10, 11, 12. I don't really need to spend too much time on this part of the timeline because we're moving everything forward, but that's the complete timeline. And you need to make sure why the 15,000 is at 5. So that's the annuity. Now there are 2 ways of looking at this annuity. This is the first year that he makes payment. 2, 3, 4, 5, 6, 7, and 8. That's one way of looking at it. And from that point of view, this is the present value of the annuity. Eight of them, and my yearly interest rate is 17%. Then I need to go from there back to there. So that means V, it's for 4 years and 17%. So that's one way of looking at it. You could also, let's do the next one in green. For 1 year after his studies, the student does absolutely nothing. He makes his first payment at the beginning of the second year after he's finished studying. Remember, this is the first year after studying. This is the end of the first year after his studies or after graduating, or that exact point in time you could also see is the beginning of his second year after graduating. So is this payment for that time period, or is this payment for that time period? The very last slide in the theory section covers this as well. So another way of looking at this, that's the first year that he needs to make a payment. 2, 3, 4, 5, 6, 7, and 8. Now if we're looking at the green bit, I'll get my answer there. This is the present value, 15,000. There's still 8 payments, so nothing has changed as to how many of them there are. Still yearly. But looking at it from this perspective, the green one, the 15,000 is made at the beginning of that time period. So I need to have the dots on top of the A. And this now needs to go back from there to there. So this is now a V5. So is it A and V4, or is it A dots and V5? Nothing changes as to what the student actually does. You get exactly the same answer in both methods. So there's no need to make any difference between any of this. It's just, how do you look at it? Does he do nothing for 4 years and then makes a payment at the end of that first year? Or does he do nothing for 5 years and then makes a payment at the beginning of the next year? And it really is semantics, depending on how you look at it. The timeline stays exactly the same. It's just making sure you understand what these dots actually do. As soon as you put begin on your calculator, how does that actually influence the answer? Without the dots, it's one time period before you make the payments. With the dots, it's actually where you make the first payment. And then V4 or V5. So please go and do it in both ways. So do the solutions answer in the textbook, page 67, or turn begin on your calculator. And then the last step will just be for 5N. And you'll see you will actually get exactly the same answer. In both cases, 33,677.